Now, please get excited for our next talk, which is titled Tackling Advanced Classification Using Snorkel Flow. This talk is brought to us by some people who know a thing or two about tackling difficult projects. Please join me in welcoming to the stage Director of Product and Founding Engineer at Snorkel AI, Vincent Chen, and Staff Product Designer at Snorkel AI, Angela Fox. Welcome, Angela and Vincent. Great to have you.
Hello.
Thanks, Rebecca.
The stage is now yours.
All right. Thank you so much. Awesome. Well, as you heard from Rebecca, my name is Vincent, and I'm very excited to be joined here today by Angela. We spent a lot of time working with customers and building the actual product to serve a lot of these use cases. So we're super excited to share some of those learnings with you today. We've worked with hundreds of customers on predictive classification problems, and we're eager to share some of the on-the-ground challenges and opportunities that we see enterprises face every day. Done right, these kinds of systems can drive really significant business value and automation. They can unlock new business lines and products while reducing costs and manual effort in major ways. So a bit of the structure for today, we'll start by sharing an overview of the shape of enterprise-grade classification, what we see in practice, and then we'll walk through 3 key challenges and opportunities at different points of the model development lifecycle. Finally, we'll share a case study motivated by a real customer use case to make some of these ideas more real and put them in the context of a problem that you might see in your organizations on a day-to-day basis. So let's start with a bit of a framing about how we think about development in AI applications at large. To put it bluntly, AI doesn't work out of the box for enterprise applications. For most complex, high accuracy, or domain-specific applications, think fraud detection, credit decisioning, custom document processing, in healthcare, patient risk assessment, the cost of incorrect outputs is extremely high. And this is true for AI models in general, but also true for large language models and foundation models. The cost of hallucinated outputs can be really high for mission critical systems. AI, just like any employee at an organization, needs to be trained, and models need to be trained or adapted using your data for your specific tasks and use cases. So given that we want to do some amount of development, what is the most effective way to build AI? Traditionally, data science teams have focused on fine-tuning models with hyperparameter tuning, or more recently, prompting. This is what we often call model-centric development. We found that in practice, the only viable way to actually build and adapt these generic models for your use case and domain is via the training data. This is the labeling, prompting, integration of other sources of knowledge to actually develop and curate and shape data sets in a way that they can actually be useful for downstream model development. This approach of iteratively developing data to improve model performance is what we call data-centric AI. And so in this section, we'll go one level deeper and talk through the specific challenges and opportunities that manifest at each stage of the development process, from task definition to your first model to long tail iteration, once you actually get to that first model and schema. When defining tasks, we often see that schema complexity leads to thrash later in the development process, and getting it right or having a flexible way to actually iterate here can be critical for teams building high-value systems. After those tasks are defined, we often see teams blocked by manual labeling, what we often call a cold start problem. And finally, even after an initial model is trained, we find that teams struggle with model-centric iteration. It often looks a bit like whack-a-mole when it comes to trying to drive down errors on critical but rare slices of data. And so at each of these steps of the development process, we'll walk through what we call a data-centric approach that we've seen our customers and users leverage to significantly accelerate their development process. Let me flip it over to Angela now to talk about the first stage of the process around task definition.
Thank you, Vincent. Next slide, please. So what we kind of see, the biggest problems that we encounter when working with a lot of our customers is really defining their ML problem. So in the case of classification, the problem is, how do we come up with a schema? All right, some customers, they will simply choose to inherit from the existing ontology and other ones will build their custom schema for their organizational needs. And unfortunately, in both cases, this kind of ambiguous schema or let's say unclear distinction between classes as a challenge is very, very common. So on the left side, you'll see sometimes the unclear distinction or what we call overlap is intentional. So in this case, the meaning of each class is designed to not be mutually exclusive. So for example, a long video can include air travel, beach travel, and cruises, all these labels that you see here, and therefore they can be classified as all of them. So we often call the scenario a multi-label schema, where we do need to identify whether each individual class is present or absent. And the overlap can also be non-intentional. It can be the result of confusion, organizational debt, or changes over time. In the business category categorization example below, you'll see even though this particular taxonomy has over 2,200 business categories, a business may still fall into more than one category. So in situations like this, the team who's working on this will often need to iterate on a crisper definition for their own business goals. And in addition to all the ambiguity we talked about here, we also find that a lot of high impact enterprise problems are also very high in cardinality. We're talking about up to hundreds, if not thousands of classes. So you can imagine that multiplies the challenge to this already ambiguous schema by many folds. So what can we do with this kind of complex or ambiguous schema situation, right? So the first opportunity is we do need to come back to the beginning and consider how we formulate the problem up front. So below, you can see two types of problem formulation. One is hierarchical on the left versus flat on the right. So in a hierarchical setting, there are multiple models and they're each performing a subset of classifications. For instance, you can first classify documents first by type, and depending on the type, you can classify then a smaller set of viable intents specifically to that type, right? So this setup, they can build an explicit hierarchical relationship up front to the extent that the schema has it. And as you can see, it is easier to split up the work because the tasks are compartmentalized by design. The downside is a little bit more setup overhead, as you can see, is a little more complicated, as well as some of the risk for error propagation. What that means is that the upstream errors may impact the overall performance later on. In the flat setting on the right, the pros and cons are simply opposite. So it is much easier to set up, as you can see, there's only one node, right? And a little bit less ambiguity in error analysis because everything is in the same place. And because there's no hierarchy built in, we will expect the model to pick up any hierarchical relationships through the training labels. And lastly, in a high cardinality scenario, you can imagine it starts to be hard to organize a large quantity of artifacts. If you have hundreds of labels, you can see hundreds and thousands of outlets, for example. And ultimately, there's no right or wrong answer, truly. The key trade-off is often between how a business decompose their problem and what the setup and management overhead that is available for the company. And once we have this initial problem formulation down, we then want to plan for some amount of schema iteration. And as we know, it's often really hard to know what the final schema is until you actually explore the data a little bit more. You might make some changes downstream. So here, the opportunity that we see is a data-centric way of iterating a schema. So what does it look like? There are a number of tools that we show here below that you can find in Snorkel. So for example, we can measure the quality of ground truth. So we're asking ourselves, have you assigned different ground truths on the same type of data in same or the same spans? If not, if that's the case, it can very likely be an error that we can correct. We can also measure the conflict between annotators. So we can trace back directly to the source of human knowledge and see the result of a correction very easily in an interactive way. And finally, we want to set it up the schema definition programmatically because changing the output label is much easier than what you will have to do in manual labeling. So this is especially true if there's a need to split or combine the labels at any time. And as we know, schema definition is something that you may need to adjust throughout your machine learning and development, not in an isolated stage at the beginning. So having a data-centric approach is very key to enable that kind of flexibility that's necessary to iterate on these complex schema as you develop your model. So after we set up the task definition, the next big phase is the path to a first model, as we mentioned earlier. So traditionally, in order to get to the first model, as we know, many enterprises to this day, they still rely on manual labeling. And a lot of complex enterprise problems, they actually would require labeling tens of thousands or even millions of data points to be able to start. So you can imagine the manual labeling stage becomes very inefficient in terms of both cost and time. For many enterprises, outsourcing to labeling vendors is a very common choice, but it comes at the risk of privacy challenges, no auditability, and simply the lower quality of data that's possible because they're labeled by non-experts. Some organizations may have access to in-house experts, right? But it's simply too high of an opportunity cost often for companies to ask these experts to label their data versus performing their primary work. And not to mention that the process can be like very slow since there are only a few of them available at the time. So what options do we have here? The opportunity we see here at Snorkel is to utilize existing resources to warm start the process in a programmatic way, which is important. So depending on the nature of the problem, an organization can either leverage internal resources like the domain experts, we're using ontology, or they can build on off-the-shelf resources with prompts and embeddings. So to combine all of these knowledge, a programmatic labeling process that we have, like what we have in Snorkel, is a pretty effective way to encode and combine these knowledge at a very short time. So let's dive a little bit deeper and see what some of them look like. In this example, we're utilizing an external standard ontology for diseases. And for a given diagnosis, we can then pull the keywords from the disease definition and turn them into ontology-based LFs. And in many cases, companies actually already have a rule-based system that they have been using over time. And this is definitely invaluable organizational knowledge that can be easily plugged into Snorkel Flow by turning them into programmatic labeling functions. And finally, at Snorkel, we're very excited about the recent advances in foundation models and large language models. We really believe that this can be a powerful approach to address the challenges of reaching the first model with that quality and very efficiently. So we made some recent investments in Snorkel Flow to make this process of iterating with foundation models a very simple operation. You can choose to perform zero-shot or few-shot learning in Snorkel with just a few clicks in the platform. And in the background, this is powered by all of our native integrations with leading foundation model providers, as you can see in this list. And we truly just want to make sure that the platform has a wide range of coverage for different kinds of machine learning problems. But as we brought up in the very beginning, like all of these resources, AI solutions don't work out of the box, right? So signals from all of these, even though they're great existing resources, they can be valuable, but they can also be very noisy. And this is exactly why Snorkel has invested in a weak supervision paradigm that can turn these noisy and weak labels into a training label with the RD noise before generalizing the model training. And I'm now going to turn to Vincent, who will talk a little bit more about this particular last critical stage, which is like kind of like the long tail iteration itself.
Great. Thank you so much, Angela. So Angela talked about the challenges of task definition, getting to your first model, and now we'll close here with one of the challenges around what we call long tail iteration. So in practice, long tail performance is critical for many enterprises. In some cases, errors on rare slices can have significant business consequences. Think, not safe for work content tags and social platforms. And, to add to this challenge, slices can change over time. Imagine political entities being really critical to get right during sensitive, election cycles, and these types of slices end up being big PR events for companies if they don't get them right in their machine learning or automated systems. So how do organizations address this in practice? By default, we've seen that a lot of organizations take on what we call these model-centric approaches, right? And this often looks a lot like whack-a-mole. Think hyperparameter tuning, where you're tweaking some parameters to try to eke out a last few points of performance. With this type of approach, it's really hard to actually get the type of robust performance gains that you need to guarantee some level of long tail performance. Even with modern methods like foundation models and large language models, prompt engineering can still feel a bit like whack-a-mole when you're trying different natural language explanations or prompts to eke out a bit of performance for models in practice. What we've seen work quite well is what we call data-centric iteration. And the high-level idea here is quite simple. It's all about looking at your data, focusing on those error hotspots, and systematically driving down the types of errors that you see with human supervision. This is an iteration loop that we see can lead to much more efficient development and actually help you systematically hill climb in terms of performance and drive down errors in these long tail data slices. So one of the key steps of this process of data-centric iteration is what we call programmatic labeling that we've referred to in this talk. This is a really powerful approach to automate and scale labeling. Rather than labeling data points one by one, you're using other resources, heuristics, rules, models, existing ontologies, all sorts of knowledge from subject matter experts to actually automate and scale up labeling. As Angela mentioned earlier, these sources of supervision can actually be noisy, and one of the key tenets of this programmatic labeling approach is that you can integrate these noisy sources using weak supervision. This is a pillar of research that we, with our academic partners, with the genesis of the Snorkel project, have worked on the academic side. And in practice, this leads to radically faster development for Snorkel users and customers. The next step that we see as critical to data-centric iteration is guided analysis, right? These are the sets of tools and approaches that eliminate the guesswork that you might see in these traditional whack-a-mole style approaches to development. A few features that we've implemented that really make this process smoother. One, fast model guided feedback. The idea being, if you're understanding where a model is generalizing and where it's failing, you can quickly identify data slices where you need to focus a little bit more attention. So having a model in the loop can actually be really helpful to, again, helping you focus on the slices of data, the hotspots where you need a little bit more attention. Integrating with modern active learning or model-assisted labeling approaches, again, can help drive these human-in-the-loop workflows where a machine is suggesting slices of data or specific data points that need a little bit more attention because the model confidence, for example, isn't that high. And finally, we've invested in a set of tools that we call tag-based analysis. The idea being we can provide semantically meaningful tags, provide humans with the ability to actually tag these fine-grained long-tail slices, and do analysis to make sure that performance on these critical slices doesn't suffer as you're iterating on coarser grained metrics like overall precision or F1. All right, so Angela will now share some of the practices that we just talked about with a case study to make them a little bit more real. This is a case study that is inspired by a real customer use case, and I'll flip it over to Angela to walk us through.
Thank you. So now let's take a look at what we mean like advanced classification case, right? In this case, let's use the video metadata as an example. So our customer in this case is a data company. They want to build an AI application to classify videos. Before coming to us, they've been manually labeling videos for a very long time into more than like 600 video categories. We talked about it before, right? Like it can just be very expensive and time consuming. And after working with Snorkel and using Snorkel Flow, our customer was actually able to produce deployable models with very excellent quality and efficiency. We're talking about like over 90% accuracy within just a few weeks. Amazing. So in the following slides, I'll quickly talk through how the customer is able to take advantage of all the opportunities that we just discussed before across the 3 development stages. So in the task formulation stage, the customer came with a commitment to say, oh, we want to use an existing taxonomy for labeling their videos, and in which case there is the established IAB video categories. And very quickly, the customer kind of decide to embrace kind of the intentional overlap of classes that you can see in the existing taxonomy. Kind of the example we talked about before, video can consist of like a number of different characteristics. And because of that, they decided on a multi-label schema format. And because of this taxonomy also come with tiers, that you can see there's tier 1, 2, and 3. They're mostly interested in tier 3. Because there's an inherent hierarchy that's built in, there is some discussion around whether it is suitable to adopt a hierarchical setup for their modeling environment. And in this case, the customer eventually had to choose a flat schema because of 2 things. Right? They really wanted to reduce the setup and management overhead. They wanted to start labeling like right away and start testing. And they also actually have a rather small team. So a single workplace is actually working better for them versus have to manage in a number of different places. And after the task structure is decided, the customer then look into the organizational resource. Cool. The customer, they're looking into organizational resources to help them warm start across the 600 classes, like we say, is very important to kind of start in labeling with like a very good foundation. So they don't have ground truth labels, which can make things a little tougher, but then the customer still decided to, they were able to utilize the zero-shot learning to be able to jumpstart their first training data creation. And after that, they then used prompt builders powered by various foundation models they can find to be able to correct any errors from an out-of-the-box result. Like we mentioned before, it may start perfect, but we can continue to use foundation model to correct and specify a number of these errors or unclear scenarios. And finally, in the long tail iteration stage, they were simply able to use a number of data-centric tools, as we discussed before. So for the supervision segment, they were able to leverage things like embedding, they're writing keyword LFs, and utilize a lot of these labeling techniques from large language model, the assisted ones. And later on during the error analysis, the key is to be able to resolve the conflict between ambiguous classes, and they'll be able to do that by using keyword conflicts and other tools that Snorkel has Snorkel has built into the platform that do not require ground truth, such as using margin distance to be able to review more examples of an error scenario. And this wraps up like a very brief case study, and I hope that this helps you see how these incredible opportunities that we mentioned can look like in context. And maybe the hope is that you can find a few situations that resonate with the AI problems that you're currently working on right now. And I'll hand to Vincent to wrap up the session.
Great. Thank you so much, Angela. So just to recap really quickly, we talked about each stage of the development process here in broad strokes. We talked about task definition and how complex and ambiguous schemas can make it really hard and lead to some thrash down the line if you're not thoughtful about the types of trade-offs that are necessary to define your problem. Even if you get started, we noted that it can be challenging to maintain the same schema over time. And we talked about a few data-centric approaches, capabilities that we have in Snorkel Flow to actually detect those errors and iteratively define your schema, which is far easier when you're programmatically labeling your data. The second stage we talked about was the path to your first model, right? And often enterprises that we see are blocked by, again, this manual labeling cold start problem. In the case study that Angela mentioned and in the broader section of overviews, we talked about how existing resources, foundation models, knowledge bases, ontologies, existing rule-based systems can actually be used to bootstrap and warm start your labeling process to get to that first model faster than you could with manual labeling approaches. And finally, when addressing this long tail of errors of critical data slices, we talked about how model-centric approaches feel a lot like whack-a-mole and how you can systematize this process using data-centric methods. Again, the idea is simple. You look at your data, you identify slices of errors, and you correct them with additional supervision. But in practice, this can actually be the highest impact and most effective way to drive robust models in production. Thanks so much for joining us. Appreciate the time and enjoy the rest of FTCai.
Thank you so much, Vincent and Angela. That was a very practical, useful talk. Thank you. We do have some questions here. And we'll start out with one that's asking for examples. The question is, what kinds of applications have you seen people build with data-centric AI?
It's a great question. I'm happy to take this one. And Angela, feel free to jump in. What we've seen in practice is that, there's really a kind of general purpose framework for developing AI. Data-centric AI we see as that kind of base, that base workflow that actually applies to all types of applications. In this talk in particular, we talked more about what we call predictive AI. So these are closed schema problems where, you have a fixed output, set of classes that you might want to target. These types of approaches ended up being extra important, right? The schema definition step, the ability to use existing systems. This is very much applicable for these predictive AI problems and leads to a bunch of use cases across industries as well. The same types of principles also apply to broader types of generative models. It wasn't in scope for this particular talk, but again, the key ideas of looking at your data, correcting errors, curating and labeling and supervising, right? Providing human inputs to, adapt data sets to your specific data or tasks is equally important in those settings. So maybe a little bit of a high level answer here, but we see this as a pretty robust and general purpose framework for any type of application.
Yeah, and I think just to add on to it, kind of similar to like the problems that we talked about before, the more complex the problem are, the more nuanced some of the differences between classes are, the more likely that you want to have some level of control over like what the problem looks like how can I make granular changes to really focus on a small area. And I think a data-centric approaches is really good at not only keeping track of these changes, but also surface these changes and help you focus versus like a model-centric setup.
That makes sense. Thank you for those perspectives. The next question is on overfitting. Where do you see overfitting being a problem with the data-centric approach?
Yeah, that's a good question. I mean, overfitting is a classical challenge that we see in any type of machine learning problem and pipeline, right? If you only focus on one subset of data, and it's not a representative set of your broader training or production distribution, you tend to see challenges with overfitting. We have specific methods in Snorkel Flow to help overcome this. At the end of the day, we see that actually looking at your data and providing these data-centric interfaces helps a lot, right? In the traditional model-centric approach, you're really just black box, training models over splits that were maybe randomly defined, and you're not really looking at the data. You're not really trying to understand whether there are distribution shifts or gaps between different splits. And the only metric you have to use is a, coarse grain split level metric to understand, hey, is, my valid set score significantly lower than my dev or training set score, right? In this data-centric approach, you actually have more tools to say, oh, the distribution of my training set versus valid set is significantly different, or, oh, this labeling function that I wrote is actually significantly overrepresented in the development or training set, that you're using to train these models. And so there's no silver bullet to overcoming overfitting in practice. But what we do find is that exposing that window and those interfaces into the data really helps you become aware, and it just gives you the tools to address overfitting in a much more direct way than, say, if you're just looking at a single split level score, right? It's a little bit of that whack-a-mole problem that we talked about if you don't have those tools at hand.
Yeah, I will add on to overfitting becomes more of a problem when the production environment that you're trying to predict on is different. Like the nature of the data is a little bit different than the nature of the training set that you have been composing, right? So not just whenever you're building this one model, but continuously understanding is the environment I'm trying to predict on changing, or is it relatively stable? And having the graphs over the differences between your training data versus like the production environment that you're implementing on is also another way for you to understand, okay, overfitting could have very short-term immediate risk versus like something that you may be able to manage over time.
Thank you for those responses and for your entire presentation. I feel much more ready to tackle advanced classification now.